Hi, today we're going to talk about energy, and we're going to talk about non-renewable sources of energy as well as renewable sources of energy. Let's look at the lecture outline. So we're going to quantify global energy consumption. We're going to look at a lot of graphs, and this is going to be a really great opportunity for you to practice reading graphs and looking at data analysis and gathering your own information from the data. So we're going to discuss how electricity is generated through fossil fuels such as coal and other sources. We're going to discuss the Hubbert curve and what that means. We're going to talk very briefly about nuclear energy, and then we're going to spend some time discussing renewable energy. So solar energy, using biomass to generate electricity, hydroelectric, geothermal, and wind are all examples of renewable energies. So, as I mentioned, this is going to be a really great opportunity for you to practice reading graphs and to we're going to look at a lot of data on the subject. So I really wanted this to be a lesson in which we spend a lot of time just interpreting graphs that are just presented in a scientific manner. So I think as this is a science course, you're going to have a great opportunity here to learn how to read these graphs. And it's going to be important for you to understand the sources of energy, both renewable and non-renewable, and just remember the key points of each method. So in the previous slides, there were pictures of oil refinery. And this is a method of gathering oil, which is present under the earth. Extracting fossil fuels from the earth are used for many reasons, but the top two reasons we extract fossil fuels from the earth is A, to generate electricity, which we use, which you can see here in the top left photograph of Times Square, and the other top use of fossil fuels is transportation. And you can see that here with all these cars driving. The method of generating electricity that now has become widespread was invented at around 1820 or 1830, and you can see by 1965 people are using electricity. It's present in a lot of households in America, and what's kind of interesting to me is that if we look at that blue curve, which is on top, we can see that the per capita energy use, so they're talking about electricity in this particular case, and per capita means per person, so the amount of electricity that every person in America uses has become somewhat stable since the 60s or 70s. And so per person, we're not using a lot more electricity than we were previously, which is kind of an interesting point. And I think we obviously use a lot more electronic devices. However, over time, these have become a lot more efficient. So any washing machines or refrigerators or televisions that were used back then were pretty energy demanding and used a lot of energy. However, our appliances today are a lot more efficient, even though we're probably using a lot more of them. So that's good news. We know that per person we're not using that much more electricity than we were previously. However, we know that if we look at the population of humans on Earth, that our population is growing almost exponentially. So we are increasing the number of people that are present on Earth pretty rapidly and dramatically. And you might imagine that this translates into a much larger energy demand. So one of the concerns is that we have a finite amount of resources to generate electricity in the manner that we're generating them currently through fossil fuels and similar methods. So there is a concern that if our population increases and people are going to be using that per capita amount of electricity each, that we are going to run out of these resources eventually. So let's look at some more measurements. So this is a graph of primary energy consumption. And you might think of this as a combination of the previous two graphs. So we saw the amount of energy use per person, and then we saw the population size. And if we kind of multiply those two graphs, we can see that this graph looks kind of like a multiplication of those two. So it really follows the trend of the increase in population. So, like I said, electricity wasn't really, the method of producing electricity that we use today wasn't really invented until around here. So that's the very beginning. Obviously, it wasn't going to be used in a pretty widespread manner at first. However, we do see that it picks up popularity pretty early on, not that long after the initial invention. And the primary method of generating electricity was through coal, and we're going to talk a little bit about how coal produces electricity. A little bit later, people started using crude oil and natural gas, and more recently, we have started utilizing renewable sources of generating electricity, such as solar power and wind, and hydroelectric, which is a very important, very widespread, pretty widespread manner of generating electricity. So let's look at another graph. Here is the primary energy consumption by source, and essentially we're looking at the same data, but we've changed the beginning of the x-axis from 1820 to about 1960. So we're looking at more recent history. So this gives us the ability to kind of spread the values out a little bit. So we have a larger dynamic range of the graph now. And again, we see coal and oil are the primary sources of generating of electricity. So those are the most used, and natural gas are the three most prevalent methods of generating electricity. And then we have small slivers on top of other renewable sources. If we look at the width of these bars here, we can see that over time we've been using oil, for example, more and more. So the width here is rather narrow, and then over time this distance here is larger, and this demonstrates that the amount of energy consumption that depends on oil is increasing over time. So we can also look at the consumption in different parts of the world. And we see here in North America, so that's that green bar here, our consumption is pretty stable since the 60s. We don't see that area fanning out significantly as we do in the Asia Pacific. So here we see that initially the consumption was quite low, but as that area developed and people had more and more access to electricity and the infrastructure was built for people to access electricity, their use became more and more widespread. So we see this bar becoming wider as more and more people have access to energy. So we do see that if we look at the distribution here, the very end, so this is almost modern day, we see that North America takes up a big chunk of the energy that that the total world uses. So by eye, you might estimate that that looks like maybe 20% or so of the total use. Asia also has a pretty significant amount of that consumption. Of course, it's important to keep in mind that there are a lot more people there. So how might that look if we start looking at individual countries? Just let's talk about the raw data. So up there you see the United States is using a very high amount of oil just as a country. So this is the oil consumption of the entire United States, and it is much higher than, let's move this over for a minute, it is much higher than other countries here. So we have Brazil, Canada, Mexico, South Africa, Bangladesh, and as a country we're using a lot more oil than any of those areas or countries. However, let's think about this in a different way. So this is as a country, but you are an intelligent scientist and you might say, well, is that really a fair comparison because different countries have different numbers of people? So let's look at it as a per capita measurement. So unfortunately, they are not comparing the same exact countries, so I don't know why they were not able to generate these graphs comparing total use per country to per capita use. I guess they didn't trust the number, the census, or the measurements that they had for the population sizes. But if we look at the per capita use for the countries that they do provide, so we have United States, United Arab Emirates, Japan, Brazil, and China, we see that per person we're actually using a lot more oil than some other parts of the world. So although China uses more oil as a country, they have a lot more people. So per person, they're actually using, looks like we're about 30 and they're about 5. So we're using about 6 times more oil per person for per person use in the country. All right, so let's look at coal. So electricity is generated in America, at least in the United States. We use coal and natural gas as a primary source of fossil fuels to generate electricity. Oil, petroleum is also used, and we use petroleum a lot for transportation, of course. So coal is, we can think of it as a main resource that we use to generate electricity. And if you look at the United States, what's kind of nice is that our consumption has kind of become flat and has evened out over time. And we're not increasing our coal consumption dramatically, although China is, as you can see from that graph. In the blue line, you have this the coal consumption increasing quite dramatically in recent times. And again, that's as a result of their industrialization and development of the infrastructure that they have to be able to support electricity coming to individual homes. Okay, so that's coal consumption per country, and then let's look at it per person. So what's nice about this graph is that they give you, in the green line, the average for per person for the whole world. The green line is the per person use of coal all over the world. And of course, not all of the world is as developed as the United States are, or other modern countries such as Japan and Germany. So in these areas, there's the electricity access is really high. Most people have access to electricity, and people have enough income to be able to pay for electricity bills, for using electricity in a way that might be more for leisure and other reasons, and we have the income to be able to spend it in a way that allows us to use more electricity. So the United States has, as a result, one of the highest consumptions of coal per person, and I think that that's a measurement, an indirect measurement of how much electricity we're using per person. That is generated from fossil fuels, of course. China, so we saw previously that their coal consumption per person, that their total coal consumption leaped up, and we see also that increase in the red line there. Of course, because of their large population, per person they're actually using less coal than the United States, and up until very recently. And other countries actually are a little bit more frugal with their energy use, or with their fossil fuel based energy use, than we are. So the United Kingdom, for example, and Germany and Japan, they are all developed countries that have managed to limit the amount of coal that they use per person. So we've mentioned a few times now that electricity is generated largely through coal, petroleum, and natural gas in the United States. And if we just look at the worldwide energy use, how is that energy generated? So about a third is generated using oil, and about a quarter is generated with coal, and about a fifth is generated with natural gas. And these all fall under the category of fossil fuels. And a little bit more than 10% is generated through renewable energy. And this includes burning wood and burning other things, other biofuels. And about 6% is through energy and electricity that is generated through nuclear power plants. Let's continue to think about this distribution and look at it in a couple of other different ways to display the data. So we're going to talk later on in the lecture about renewable energy. So let's break up the types of renewable energy that we use. By and large, the most abundant renewable way of generating electricity that we use is through hydroelectric, so using dams and rivers and the ocean to generate electricity. And biomass is probably the second largest, so that includes burning wood and making ethanol from corn and making other types of oil from other types of vegetables, and using that to burn the biomass and to generate energy. And then wind is up there as well, and then we have solar, which is a smaller proportion, and geothermal, which is the smallest proportion of renewable energy that we have so far. So how are we using these resources, and what are we using them for? So we have petroleum, natural gas, coal, renewable energy on this left-hand panel. This is kind of a confusing way of showing the data, but I like it because they include the numerical values on each of these lines. So all of these sources of energy go to either end use, so in these yellow bars on the right here, or go back into generating more electricity, so in those black and gray bars. And they're also showing you that 25% of that is just lost, right? So we've talked about the second law of thermodynamics and how every time you transform energy from one form to another, you're going to lose some to a significant amount of it to the system. So you can't conserve all of that energy. If you burn 100 calories of oil, you're not going to get an equivalent amount of electricity out of that. So petroleum is our primary resource that we use. And if we look at the yellow bars on the right, the primary use for all of these sources of energy is transportation. And then we have electricity for industrial purposes, residential purposes, commercial purposes. Keep in mind that some of these measurements are for different years, and there is a little bit of discrepancy between these graphs, but by and large I think the proportions are pretty much accurate. So transportation, and that is largely just personal use, right? Personal transportation. So let's look at some more data measurements. So about a third to more than a third of all of our energy goes to just driving around in our cars, and then the rest is electrical use, industrial and personal electrical use, and commercial. Okay, so this is basically the same information from another source who graphed it, and let's see how their numbers add up. So in this way, they're showing you again a pie chart, which is, I think, a reasonable way to visualize the data. So they're showing you again petroleum, natural gas, nuclear, renewable, and which sector uses this energy the most. And transportation is on the right here in this brown wedge of the pie, and we can see that transportation uses a pretty significant amount of the energy here, and we'll show a breakdown of the transportation use very soon. Industrial electricity use is 10%, just industrial use of energy is 20%. Resident electricity in a residential use is about 15%, so that's the electricity that you use in your home. And this is all United States numbers, by the way, so this is 2012 measurements of United States consumption.